In this video, we're going to look at continuation methods. Not the type in the task namespace or task parallel library, but the type which are enabled by the yield return feature in C#. You'll see how they enable a composable approach to manipulating data and how they enable such to be done without multiple iterations of enumerables. Before we get into the continuation method stuff, let's just review what yield return does. For each loops, as you'd be aware, work on a pull mechanism. So it pulls the next item once it has processed the current one. The debugger will only enter the getNames method once the iteration begins, not when it actually gets hit itself. You can see multiple yield returns in that method. Each one delivers its item when the for each loop calls for the next one. So we get a lazy evaluation. The yield return statements set up a state machine whereby it returns to the place where it was up to with each invocation from the for each loop. Okay, so let's clean this up and then we'll go about looking at how we can examine continuation methods. So I've got this class over here called myAPILib, and it's got a couple of methods here. So we are passing in an array of strings to the makeUpper method. That returns an IEnumerable, which we in turn pass to the trimString method. The way this works is that the first item in the array is processed by the makeUpper method, and then it is processed by the trimString method. So at a glance, you would think that it first makes the whole array uppercase and then makes the whole array trimmed in 2 iterations of the array. But that's not the case. It does both operations in one pass, and it is completely composable. If there were 10 such operation methods, it would do the 10 operations in one pass. So you can see here in the console how it is performing both operations in the one pass, and the yield return magic is also visible where it returns to the inner for each loop at the point at which it left off to continue. And this is why we call them continuation methods. It's the state machine at work. And this is how LINK works. So let's go back to myAPILib, and I'm going to just drop in a method from the toolbox called doOperationLink. And it's calling a method called getTrimsUpperStrings, which you can see is passing in the same list as before, but we're performing 2 selects on it, and those are link selects. And link is implemented using the decorator pattern. And so it basically creates a pipeline, which is similar to the composable pipeline that we created above. And both of the operations in those selects are performed on each item as it goes through. So there's not 2 iterations, there's only 1 iteration. So let's now invoke a new version of the method using link, and you'll see that we get the same result without the log messages. The final thing we're going to do is run a benchmark. So I've installed the NuGet package benchmark.net, and you can see I've added the relevant attributes at the class level. I want to benchmark doOperation continuation and doOperation link, so I've added the attributes there as well. I'm removing the console write line statements because they impact performance, and we should have a pretty close benchmark now. So the first thing we do is we build the project in release mode. So I'll do that now. And then we just run the DLL using the .NET command. Okay, I've gotten rid of all of the cruft. That actually takes quite a while, but I mean, that's amazing. It's the exact same performance with those two, the same mean performance with those 2 different methods. So I hope you've enjoyed my video today on continuation methods.